22 and a half hours, give or take. That's how long it takes a single signal to crawl from the most distant human-made object in existence back to Earth. 22 and a half hours of silence, waiting to find out if the answer that finally arrives even makes sense. In late 2023, it stopped making sense entirely. Voyager 1, humanity's furthest traveler, started sending back something that looked less like scientific data and more like static garbage, a stream of ones and zeros that meant absolutely nothing to the engineers reading it. For months, nobody knew whether the spacecraft was dying, malfunctioning beyond repair, or simply confused after decades of nonstop operation in the coldest, emptiest environment humans have ever sent a machine into. And what took nearly 2 years to fully untangle turned out to be only the beginning of a much stranger story. To understand why this mattered so much, you first have to understand just how far Voyager 1 actually is. Launched in September 1977, it flew past Jupiter, then Saturn, using their gravity to slingshot itself deeper into the solar system before finally crossing into true interstellar space in August 2012, the boundary where the sun's influence effectively ends and the space between stars begins. Along the way, it captured some of the most iconic images ever taken of the outer planets, including the very first close-up views of Jupiter's raging storms and Saturn's intricate rings, before its mission quietly shifted from planetary exploration into something almost nobody had planned for at launch. A decades-long journey into completely uncharted territory that continues to this day. Today, it sits more than 24 billion kilometers from Earth. So far away, light takes almost a full day just to reach us one way, a distance that grows a little larger with every passing second. It is still, to this day, the most distant spacecraft humanity has ever built. And remarkably, after nearly 50 years in the vacuum of space, its instruments are still switched on and still listening. That kind of longevity comes at a cost, though. Voyager 1's onboard computers are built on technology from the mid-1970s, with less processing power than a modern digital watch, and every single year, cosmic radiation and sheer age chip away a little more at its fragile hardware. Engineers back on Earth work from documentation and institutional memory decades old, some of it passed down from colleagues who have long since retired, just to keep track of exactly how this particular spacecraft's aging systems tend to behave. In November 2023, that decay finally caught up with it. Voyager 1 began transmitting a steady radio carrier signal, proof the spacecraft was still alive and listening, but the actual science and engineering data riding on that signal had turned into unreadable gibberish, a stream of noise where clean numbers used to be. Something inside the spacecraft was broken, and nobody on Earth could simply fly out and take a look. Engineers eventually traced the fault to something called the Flight Data System, one of Voyager's 3 onboard computers, responsible for packaging science and engineering data before it's beamed home. Somewhere inside its aging memory, a singlet chip had degraded after decades of exposure to cosmic radiation, corrupting a small section of code the computer needed to format its own data correctly. It's a little like a single damaged page in an enormous instruction manual. Except the manual is 47 years old, floating in deep space, and nobody has a spare copy sitting on a shelf. There's no way to send a technician out to swap in a replacement part, no way to physically inspect the damage up close. Every single diagnosis had to be made indirectly, by carefully reading the pattern of a signal that no longer carried any usable information at all, like trying to diagnose an engine problem purely by listening to a faint, distorted hum coming from underneath the hood. In March 2024, the team tried something engineers affectionately call a poke, a command designed to nudge the flight data system into trying different sequences within its own software, just in case a workaround existed somewhere inside its corrupted memory. Nobody knew for certain the poke would work. It was, in essence, an educate to get sent out into deep space, built on decades of institutional knowledge, about how this exact piece of decades-old hardware tended to behave when it ran into trouble, mixed with a fair amount of hope that 50-year-old circuitry would respond the way modern engineers expected it to. Each attempt took nearly 2 full days round trip, sending the poke out, then waiting patiently through that same 22-and-a-half-hour stretch of silence for any kind of reply. On March 3rd, something changed. The returning signal still wasn't normal telemetry, but its structure was different enough that engineers could tell the poke had done something. They just didn't yet know what. It took weeks of careful analysis to figure it out, weeks of comparing the strange new signal pattern against old records and educated guesses about which part of the memory might now be readable. Eventually, the team managed to identify where the corrupted code was hiding and, remarkably, found a way to rewrite the necessary functions and relocate them to working memory elsewhere on board, all without ever physically touching the spacecraft, using nothing but carefully worded radio commands sent across a gap of more than 20 billion kilometers. Splitting that single damaged section of code into smaller pieces and storing them across several different working memory locations meant no single future, glitch could take down the entire system quite so completely again. A small but meaningful improvement squeezed out of nearly 50-year-old hardware that was never designed with this kind of flexibility in mind, engineered decades before anyone imagined it would still be running today. By April 2024, readable data was flowing again, and after months of silence, mission engineers finally understood what had gone wrong. You'd think that would be the end of the story, a satisfying engineering triumph, decades-old hardware nursed back to health by a small, dedicated team who refused to let their oldest spacecraft go quiet. And for the memory glitch itself, it was. But here's where things take a genuinely strange turn. Because once Voyager 1 started speaking clearly again, what it had to say turned out to be something scientists still can't fully explain, and it has nothing to do with broken hardware at all. Back in 2021, years before this whole computer crisis even began, researchers at Cornell University had been quietly combing through Voyager 1's older data and noticed something odd. In between the occasional bursts of plasma oscillations triggered by our own sun's outbursts, rippling out across the solar system like shock waves from a storm, there was something else sitting underneath. A constant, extremely faint, almost perfectly steady hum sitting in a narrow slice of the radio spectrum coming from the interstellar plasma itself. Not a burst, not an event tied to any solar activity at all, just a continuous, low murmuring signature that never really switches off. Astronomer Stella Koch-Ocker, who led the discovery, described the interstellar medium almost like weather, quiet most of the time, occasionally disturbed, but never actually silent if you know exactly where to listen for it. A subtle background presence hiding in data that had already been sitting on Earth for years before anyone noticed it was there. At first glance, this might sound like a minor curiosity, background noise easily explained away. It isn't. Before this discovery, scientists believed the only way to measure the density of plasma in interstellar space was to wait for a genuine disturbance, a shockwave from the sun rippling outward and rattling the plasma enough to detect it, the cosmic equivalent of only being able to check the weather during a thunderstorm. This persistent hum changed that completely. It meant Voyager 1 could report on the density of the material, surrounding it constantly, continuously, without needing the sun to cooperate first, but nobody has fully nailed down exactly why this hum exists at all, or precisely what's generating it with such remarkable, narrow, almost deliberate steadiness. The leading scientific explanations involve something called thermally excited plasma oscillations, essentially natural vibrations rippling through the electrons scattered across interstellar space, stirred up by heat rather than any dramatic external event. Another possibility is a phenomenon researchers call quasi-thermal noise, a kind of background static generated simply by the constant chaotic motion of charged particles drifting through the emptiness between stars. Both ideas are plausible, and both fit reasonably well within existing models of how plasma is expected to behave in such a sparse environment. Neither one has been confirmed with certainty, and researchers openly admit that pinning down the true mechanism will likely require new data, possibly from a future mission built specifically to study interstellar space up close, since Voyager 1's instruments, however remarkable, were never originally designed with this exact question in mind. And here's the part that makes this even stranger. When engineers finally restored Voyager 1's readable data stream in 2024, after untangling the corrupted memory chip, that same persistent hum was still there, threaded quietly through the newly recovered data, completely unaffected by the very computer crisis that had nearly silenced the spacecraft entirely. While the wider world was worried about whether Voyager 1 could even talk to us anymore, the plasma itself just kept humming along in the background, indifferent to whatever was happening inside the spacecraft's aging circuits. Scientists have used that steady signal to detect something else too. Small-scale density fluctuations rippling through the interstellar medium across distances of just a few astronomical units. Hints of turbulence in a region of space so thin and so quiet that almost nothing was known about its fine detail before Voyager 1 arrived there. Nobody had ever measured interstellar turbulence this directly before, simply because nothing built by humans had ever traveled far enough to listen for it. Every data point Voyager 1 sends back now effectively rewrites what a small patch of our galaxy's environment actually behaves like, at a scale we've genuinely never been able to observe up close, one faint radio measurement at a time. Researchers describe this as being able to sample the density of the material. Voyager 1 is currently passing through almost continuously, rather than waiting for a rare, dramatic event to briefly reveal it, giving scientists a running, near-constant readout of an environment that had previously only ever been guessed at from models and indirect calculations. Put those two threads together, the solved computer mystery and the unsolved plasma mystery, and you get a strange kind of layered story. One mystery came from a spacecraft slowly falling apart after nearly 50 years of continuous operation. patched. Together by engineers thousands of light minutes away, using nothing but patience and clever code. The other mystery isn't about the spacecraft breaking down at all. It's about something Voyager 1 is detecting out there in the genuine emptiness of interstellar space. A phenomenon that exists whether or not the spacecraft's computers are working properly, quietly humming along at the very edge of what we've ever managed to explore. It's a strange kind of layering human engineering. Being fixed on one level while a genuine cosmic mystery keeps unfolding on another, both stories happening at once, carried across the same fragile radio link. Voyager 1's power output keeps shrinking too, losing a small amount of electricity every single year as its nuclear power source, a radioisotope thermoelectric generator built in the 1970s, steadily decays, forcing engineers to methodically shut down non-essential systems just to keep its most important instruments alive a little longer. Heaters have been turned off on instruments that, by all normal engineering expectations, should have frozen and failed long ago, yet somehow continued operating anyway, sitting in temperatures far colder than their original specifications ever accounted for. Estimates suggest it may only have enough power left to keep transmitting usable science data for a few more years before it finally goes silent for good, this time permanently. Its long journey outward finally coming to an end, far beyond anything its original designers in the 1970s ever expected it to achieve. The mission was originally planned to last around 4 years, just long enough to fly past Jupiter and Saturn and send back a handful of photographs before quietly ending. Instead, it has now been running continuously for close to 5 decades, quietly outliving almost every prediction ever made about it, and outlasting the careers of many of the original engineers who first built and launched it back in the 1970s, which makes that quiet, persistent hum feel a little different once you think about it that way. A signal humming steadily through the near vacuum of interstellar space, still not fully explained by modern physics, beings reported back to us by a machine older than most of the people currently working to keep it alive, using a communication system that takes almost a full day just to say hello. Somewhere out past the edge of our solar system's protective bubble, something is quietly ringing, and we genuinely still don't know exactly why. For now, all we can really do is keep listening, transcribing that faint signal one careful transmission at a time, and hope Voyager 1's remaining power holds out long enough for someone, somewhere, to finally work out what's actually causing it, before this remarkable aging traveler finally falls silent for good. If mysteries like this genuinely fascinate you, go ahead and like this video and subscribe, because there are plenty more strange signals and unexplained discoveries from across the solar system still waiting to be covered on the S channel. What part of Voyager 1's story surprised you the most? The broken memory chip that engineers fixed from 20 billion kilometers away? Or that steady hum nobody can fully explain even now? Drop your thoughts in the comments, because honestly, after everything this spacecraft has survived over the last 5 decades, I don't think we've heard the last strange thing it has to tell us.